Here is a tutorial of how we scan a thin section of rock or concrete using a whole slide scanning software from Microvisioneer. It's called manualWSI, whole slide imaging software. We use that to scan a 50 by 75 millimeter thin section of concrete or rock on a stereo microscope. We use Olympus SZX stereozoom microscope, which has a transmitted light, a reflected light, and a fluorescent light attachments. We use the transmitted light base, the transmitted light mode, to do the scanning of the thin section. Here is a thin section of concrete impregnated with a fluorescent dye mixed epoxy. I'm going to show you how to scan this thin section. It's a 50 millimeter by 75 millimeter 2 by 3 inch size thin section. We attach a manual XY stage at the base of the microscope. So this stage is glued to the base, to the transmitted light base, with a double-sided tape so the stage doesn't move. And we use these clips, sample holder clip, to attach to transparent ruler on both sides. So we don't attach the clip to the thin section, but we put two on both sides and put the sample in the middle so sample doesn't move during scanning. Like that. And turn on the light. Only the transmitted light. We don't need the reflected light, or we don't need the fluorescent light. We just use the transmitted light at the maximum illumination of the light. We use a fiber optic light. It's very important to get bright light source to do the scanning of the thin section. So we use these leads fiber optic light with gooseneck, the Fostech gooseneck that comes on the back of the microscope. And then we scan the thin section with a Basler industrial camera attached to a C-mount adapter, a 1X C-mount adapter. And this industrial camera, the three important requirements for a camera to use for whole slide scanning are: it has to have global shutter, it has to have high frame rate, and it has to have high resolution. So we use this Basler ACE2500 60 UC camera, where 2500 stands for 5 megapixel resolution, 60 is the 60 frames per second frame rate, and UC is the color USB 3. We need the USB 3 camera for the fast scan. So the high frame rate, USB 3, and global shutter are the three requirements, and this Basler camera works really well for high-speed scanning of the thin sections. And the software that we use is a Windows-based platform, Windows software. And I'm going to show you the software, which is this one, called manualWSI. That's the software. So to start with the software, before you do any scanning, you have to set the presets. For each microscope, you have to set the preset for each objective magnification. This particular microscope goes from 7x all the way to 90x. But the higher the magnification, it takes the longer time to scan the thin section, and the file size of the scanned image increases significantly. We usually stay at 10x magnification At 10x magnification, we can scan the entire thin section in 5 to 6 minutes, and we get a very high resolution scanned image, which we can magnify for a specific area of interest, and we can crop different areas of interest and still retain a good resolution. So 10x is kind of a sweet spot to do the scanning, and we stay at 10x magnification. You can choose any other magnification, you just have to set the preset for that. Since as you change the magnification, the brightness of the image decreases with increasing magnification, so you have to make the screen brighter by moving the brightness bar in the preset to set the preset. Now the microscope also has a polarizer and analyzer attachment. The polarizer is placed beneath the stage, beneath the XY stage, and the rotating analyzer is on the top attached to the objective. And when you rotate this analyzer ring, you can go from plain polarized light to crossed polarized light mode just by rotating the object or rotating the analyzer ring. You can get the plane to cross polarized light mode. So to set the preset, first you have to remove the sample and put a blank glass light to do the shading compensation. You have to set the preset and shading compensation with this blank glass light. But before I do that, let's put the sample back, since I want to see the brightness for setting up the brightness bar. Here I already saved the preset. I don't want to change that 10x preset, but just for demonstration purposes, I want to take a new preset. So click the plus sign and say choose a new preset, 10x new. Once you set the preset for objective 10x, then you have to choose the objective lens magnification. The objective lens magnification for 10x, it will be 1 for a 10x objective. And the sensor of the Basler camera, the sensor pixel size is 4.80 micron per pixel. So each pixel is 4.80 micron. Then you have to get the camera adapter magnification. Now to get the camera adapter magnification at 1.06, at the resolution, the final resolution with that adapter magnification will be 4.52 micron per pixel. I'm going to show you how to get these values from the sensor pixel. What you have to do is you have to remove the sample and put the scale bar, the transparent scale bar, in the middle. Here is the scale bar. Once you place the scale bar, you make sure it's focused. Once it is in focus, then you take a scan of that scale bar. You go to accept scan parameter. You don't have to move the stage. You just choose that scale bar and you save it. You save it as a scale bar, and once you save it, I already saved it before, so I'm just replacing it. Once you save it, then this is a millimeter scale bar. Then you minimize the manualWSI software and open image analysis software. Open the scale bar that you just saved. Draw a line from center of one vertical line to the other to get 1 millimeter distance, and then you go to analyze, set scale, and this is 210 pixel. All you need is this number. 1 millimeter known length corresponds to 210 pixel, which means 1 millimeter is 1000 micron, so 1000 micron is 210 pixel. So you don't have to save it, just close it, go back to WSI software. So 210 pixel is 1000 micron, so each micron will be 4.5 micron. Each pixel will be 4.5 micron. Since 1000 micrometer is 210 pixel, each pixel is 4.5 micron. That's how it comes. Now since you know the resolution 4.5, you divide the sensor pixel by the resolution to get the 1.06. So that's how the 1.06 came. So you get a scale bar, you scan the scale bar image, you open image J, you see how many pixel corresponds to 1 millimeter, which is 1000 micron, then you know that how much micron 1 pixel is. So that's how this camera adapter magnification is selected. Once you select those two, then you have to play with the brightness, gain, blue, green, red values, white level, black level, gamma value, and the frame rate. You have to play with those. So remove the scale bar, move it to the side, put the sample of a thin section. Then you play with the brightness, you make your magnification, you make your illumination of the light maximum, and then keep the gain as low as you can, increase the brightness, play with the focus, make sure it's sharp focus, and then you move the stage to make sure it has adequate light. Then you remove your sample, put the blank glass slide. With the blank glass slide, you do, once you set up your brightness and gain and gamma and RGB values with the sample, you put the blank glass slide. You have to do a shading compensation. To do the shading compensation, you say acquire new shading compensation, prepare shading compensation. All you have to do is just to move the blank glass slide in back and forth direction just for a few seconds. Just for a few seconds. Then you say perform shading compensation. Then it will give you a value for the shading compensation. Once you did the shading compensation with the blank slide, you just go back and you update your existing preset. Once you update your existing preset, you are done. That's how you set the preset for 10x new. So every time, now if you close the software and open it again, you will have the set preset. You don't have to do it every time. You do only one time and that preset stays for your future scans. So that's how you do the setup of the preset. You do the objective lens magnification, camera adapter magnification, and then shading compensation. Those are the three things you do. Then you put your sample. Put your transparent scale bar, the flexible transparent scale bar at one side, then another sheet, plastic sheet on the other side so the sample doesn't move. And then you go at one, I go at one edge of the sample so I can see the scale bar, and that's kind of the border of the sample and the scale bar. I see some hair or fiber there. Airborne fibers are everywhere. Oops. Usually I make sure that my sample is clean, no airborne fiber or anything shows up in the scan. Okay, so I start with the edge. I use a thin film of oil on the thin section. I don't put cover slip since I do SEM work after optical. I keep the thin section uncovered. I put a thin film of refractive index oil. So I start from the corner. This is the corner of the thin section, and this is the transparent scale bar. I start scan from here. I already have my preset ready. I go to adjust setting, and then it's ready to scan. There are a couple of things to remember. Number one, you don't change the brightness of your light. It stays the maximum value where you set your preset. Number two, when you scan, you make sure you have about 20% overlap between two rows of scan. You do the first row, then 20% overlap. It's very important you have 20% overlap between two successive rows of scan. And then third thing is you don't scan too fast, you go slow. If you go too fast, then you will have something called image blur, where certain areas of the final scanned image you will have out of focus, blurry area, blurry patches. You can remove that image blur by reducing the scan speed, by making sure that you set your preset values correctly, the brightness, the gamma, the gain values correctly, and you scan it slowly, and you have about 20% overlap. Okay, so you're ready to start scanning. When you scan, this is the active area. In this active area you have some grid lines. These grid lines are helpful to decide the 20% overlap. Then you will have a top right corner where you will see the portion of your actual slide that has been scanned. Camera on, grid on. You don't need to keep you should keep the grid on so you can see how much overlap you are having between successive scan. Everything ready. And this red area is the active area of the scanned image. And then once you start to scan, it will turn to green when you can start scanning. And there will be a focus bar you will see on the top, which will make sure that you have sharp focus. And usually before I start the scan, I go in the middle of the sample and I play with the focus to make sure that I have sharp focus. And once you start the scan, you will see a horizontal focus bar on the top. I just want to make one pass to make sure that that's the edge of my thin section. That's the edge of my thin section. I want to make sure that I'm perfectly horizontal, so I don't get an angle, a diagonal scan. I just want a horizontal scan. So I just want one first east-west traverse to make sure that the glass slide is oriented properly. Okay, so we're ready. So ready to scan. Once you're ready to scan, the red box turns green and you get a view on the top right corner. And now I start moving my XY stage. I go the X direction first, then I rotate the Y direction. There you go. When you start scanning, you see the focus bar on the top. That's the horizontal bar. Now if I stop at one point and if I play with the focus, if I play with the coarse focus, you see if I go out of focus or in focus. When I go out of focus, you see the focus bar going down, and when I come back to focus, the horizontal bar gets longer. So at the sharp focus, you get the maximum length of the horizontal bar with a blue line and a red line. The red line is the maximum length at the sharp focus of your horizontal bar, and the blue line is where your focus actually is. So you have to make sure that your blue line stays close to the red line. You get the maximum horizontal bar at the sharp focus. So during your scan, you have to make sure that your focus bar is maximized, which is about half the length of this active square. So let's continue the scan. It will give you the frames per second at the bottom. It will show you the time since you started the scan, 1 minute 44 seconds. It will show you the frames per second, 35. If you go too fast, your focus bar gets smaller, so which means it's getting out of focus. So you need to slow down, and if some areas get out of focus, you can come back and then go back again. It shows the portion that has been scanned in the top right corner. Now you go to the second row. You keep about 20% overlap, which is about 2 grid size, 2 square grid size. You keep 20% overlap. Then you continue from west to east. Keep an eye on the focus bar so you have good sharp focus during your scan. I usually include a portion of the scale bar for the scale. This concrete sample has a urethane coating. You can see that dark urethane coating with quartz filler. Then you go to the third row, and again you keep 20% overlap, and then you go again from east to west. It's important that you don't go too fast. It's important you keep 20% overlap. It's important you keep the focus bar that you are in focus all the time. And if you feel that you are getting out of focus, you can stop and readjust the focus with the quartz focus knob. This concrete is impregnated with fluorescent dye mixed epoxy to highlight the air voids and cracks. Air voids, you can see, are highlighted by the yellow fluorescent dye. Make sure you have 20% overlap. Usually it takes about 5-6 minutes to scan the entire 50mm by 75mm thin section at 10x objective for plain polarized light, and then another 5-6 minutes at crossed polarized light. So around 10-12 minutes you can scan the entire 50 by 75mm thin section at both plain polarized and cross polarized light mode. And once you finish the scan, you can use many third-party whole slide scanned image viewer like QUpath or CDIN viewer. I'm going to show you those after the scan is done. Those third-party viewers can open this whole slide scanned image from Microvisioneer, and then you can enlarge, see specific areas, crop specific areas, put scale bar. You can do all processing after the whole image is scanned. I use the QUpath and CDIN softwares for viewing and enlarging and cropping. I use image J to put scale bar. Although this software, manualWSI software, will give you a scale bar at the end of the scan, when you save it, it will give you an option to save in the JPEG mode or TIFF mode or JPEG with scale bar. So you can have a scale bar at the end of the scan. But your image is, if the image is too big, then you can put a larger size scale bar with the third-party softwares or image J. There's the last scan. That's the end of the slide. You see the focus bar is always at the maximum level to have the sharp focus during the scan, and this speed is pretty comfortable to go. And there at the end you can see the entire image has been scanned. I'm just making one vertical traverse to make sure that I have the end of the glass slide entirely. You can go back and forth if you need to make sure your entire area is covered. Okay, so that's pretty much the entire section. Now you save it. You go to save, and you see JPEG and scale. It's giving you different options of saving. You can save as a TIFF mode, which is the common one, and when the file size gets really big, it automatically saves in the TIFF mode. It doesn't give you JPEG if the file is too big. SVS file is good to save when you see CD-in viewer or other third-party software, but JPEG can be opened, and there is a JPEG with the scale. That's the option I'm choosing, JPEG with the scale. And let's give a name of this file, PPL1, PPL. Let's make it capital. PPL, that's a plain polarized light scan. You save it. And now I'm going to open the PPL later. I want to do the crossed polar scan now. So I can start from where I ended here. I just have to go back to the starting point again. I don't need to save the, yes, I want to reset the scan data. And now it's ready to scan. Now before I scan, I rotate the polarizer, the analyzer ring, the analyzer ring to 90 degree. So I get the cross polar. Once I'm in the cross polar, now I start my scan. In the cross polar, I can start from there, ready to scan. So now I'm scanning it in the cross-polarized light mode. In the cross-polarized light is helpful to see the distribution of aggregates, the coarse aggregate and the fine aggregate in the concrete, especially the siliceous aggregate, the calcareous aggregate, crushed limestone, for example, in this case, granite in the coarse aggregate, silica sand, feldspar in the fine aggregate, limestone and dolomite particles in the fine aggregate. All those are clearly seen in the entire slide. The distribution of these particles, that's the especially important part for the whole slide scanning with this software. You can see the quartz sand in the urethane coating. Make sure you keep 20% overlap. And the carbonated paste, the carbonated Portland cement paste, the golden yellow bilifringence of the paste can be clearly seen when you do the cross-polar scan. So you can see the limestone particles in the sand, the subordinate amount of limestone, the major amount of crushed siliceous particles, quartz, feldspar. You can see the albite twinning in the potash feldspar. You can see the crushed granite, dolomite, mafic minerals. All these are seen. There's a perthitic feldspar. There is the albite twinning, the albite lamellae, the granite sample, All the aggregate particles are seen in this cross-polar view. %20 overlap. And the dolomite sample coming. Mostly the fine aggregate is crust, quartz and feldspar with a subordinate amount of limestone dolomite. Actually, when you do the scan, you can do a significant part of your petrographic examination that you do only looking in the microscope. Instead of looking through the microscope, you can look on your computer screen while you are scanning and do a major part of your petrographic examination. You can do the air content, the air void distribution, the cracks, the crack distribution, the paste, the porosity of the paste, distribution of the water cement ratio in the paste. All those information you can get from the plain polar scan, whereas the aggregates, the coarse aggregate, the fine aggregate, the crust stone, the gravel, the carbonation of the paste, all those information you can get from crossed polarized light scans. So these two scans, these 10-15 minutes, you can see carbonation of paste around the dolomite aggregate particle here. All those information you can obtain when you are doing your whole slide scan. So this is an important part of the exercise during petrographic examination. You can do, you not only get the information during scanning, but you have an archive of the whole thin section now, the plain polar and cross polar at high magnification. So if you accidentally break your glass slide or lose your glass slide, or years after your job is done, if you want to go back, you always have a digital archive of the entire thin section, which you can go back and see and magnify different areas to see the composition and the microstructure of the concrete that you have scanned. The dolomite, then came a granite, limestone, all the crust stone particles, then you have the fine aggregate. So you can find out all the information from your scan. 20% overlap. Every time you do the next row, you make sure you keep the 20% overlap during your scan. And again, this speed is fine. 5-6 minutes is all it takes. No need to go faster, and then you end up an image with blurry patches here and there. From image blur, you don't want to do that. This is done, but I still want to stay a little higher. So I have about 20% overlap, and I will make another run at the end. This is much better way of scanning than taking multiple images and stitching in the stitching software. Earlier I used to take about 40 images to cover the entire thin section, then use Microsoft Image Composite Editor, ICE, I-C-E, Image Composite Editor. That's a beautiful software that I used to use before, but you have to take about 40-50 images, again around 10% to 20% overlap to cover the entire slide, and then bring those images to Microsoft ICE, and the ICE will stitch them nicely. That's how I used to do by image stitching of multiple images, but now I just scan those images, because during the scanning I can concentrate more on what I am seeing and keep a record in my brain of the aggregate, of the paste, of the carbonation, of the air content, air void distribution, paste density, porosity, distribution of paste, coating, how many coating layers I have, what kind of mineral fillers are present in the coating. All those information I'm getting while I'm scanning this in my monitor. So this is a better approach to do the scanning, digital archiving, as well as doing petrographic examination of the thin section. So that's the entire slide in the cross polar. Now you want to save it. I'm going to just go to PPL and rename that, remove the P by X to have the XPL scan. Save that. So once your both scans are done, I bring the stage back to the 0 position, turn off the light, close the software. Now I'm going to open a image viewer. I'm going to open this. First I'm going to open this. There are 3 third-party whole slide image viewing softwares. One is called Zoom, other is called QUpath, and the third one is called Sidine Viewer. I'm going to open the QUpath. And then get the saved image, the PPL, bring it to the QUpath. You just drag it. This one is about 37 megabyte and the cross polar is about 42 megabyte. The entire scanned image is about 37 to 42 megabyte. It takes a while to open the big image. Here is your entire scanned image. Now all you have to do is use the mouse, the wheel in the mouse. You move the wheel to magnify. You can see I'm magnifying. You can see the inset here of the entire scanned image, and the boxed area is showing the enlarged portion. You can move at different areas of your scanned image and it will show you those areas. You can see beautiful high resolution image you are getting from this whole slide scan. Beautiful scanned image. Your scale bar is there, so you know the millimeter scale bar, and you can see the urethane coating. You can see there is a neat urethane coat at the base, then quartz sand filler in the urethane coat, the air voids, the water voids, entrained air, interstitial space between the aggregate particles that are filled with epoxy. You get a lot of information. The most important thing you do next, once you get the scanned image in the plane polar, is go to image J and do a binary image to highlight the air voids. And you can do the air content, you can do the air void distribution, the air void size distribution, the specific surface, the void spacing factor, void frequency. All those information can be retrieved from this whole slide image by using the image J followed by the flatbed scanner method of the procedure C of ASTM C457. You can use that procedure C on this scanned image to highlight the air voids in white against everything else in black. So a lot of things can be done. You can do the grain size distribution of the sand. You can determine the sand content by image J. So a lot of image analysis can be done once you have a whole slide image at such a nice high resolution. Now QUpath is nice. It shows you the top right corner, the entire image, and then you play with your mouse, with your wheel, mouse wheel to magnify. You can really magnify. You can see how small area I'm looking here. Just a tiny little area in the slide, and you still have nice resolution. So it really gives you a high resolution image, whole slide image. And now let me show you the cross polar one. You just bring the cross polar one on top of that. Well, why not show you the cross polar image in the other? Here it is. Let's close this one. Open the scene viewer, the other whole slide viewer, and then again you drag the cross polar one in the scene viewer from path core, scene viewer. Here it is. You can crop the image. Here you get a magnifying glass, and again in the top you get the entire slide. You use your mouse wheel again to go in different areas of your scanned image. Like that, and then I can crop different areas. What I usually do after I get the scanned image, this is what I do. I make a duplicate first. So I create copy, and then paste. So it creates a duplicate. Same thing, I make a copy of the PPL and then paste. I create a duplicate first. Then I can use the Windows viewer, and then I go to edit, and I crop the portion that I don't want, because usually when I scan I go a little more than the edge of the glass slide, so I can crop the edges. Here is the scale bar. You can see the scale bar, that JPEG with scale bar that gave the Microvisioneer manual whole slide image software gave you the scale bar. And I still have the scale bar with my transparent scale bar, so I can see the millimeter scale. And then you can play with the adjustment if you want a little bit. You can brighten the image a little bit. You can play with the adjustment, color, clarity. I stay around 50 to make it little sharper, and then you can save it. I say PPL copy. Once I save it, then I can open this copy in the image J. I can open this. I don't change the original scanned image. I don't touch the original image. I create a duplicate, then I do all the processing in the duplicate one. So go to PPL copy. So image J will open that. Now the scale bar is still there, but what I do is I use the magnifier to magnify it a little bit. Then I use the horizontal line and I draw a horizontal line, and then I say set scale. You really don't have to do it because it remembers from your preset the scale bar. So if I can do it. I can say the known distance is 1 millimeter. It will put the scale bar, but let's not do it. Let's put the scale bar directly. Go to Analyze, Tool, Scale Bar, and if I say I know that my 1 millimeter is 1000 pixel, I can put that, so get the pixel, or I can use the scale bar that Microvisioneer gave, This is the 5 millimeter, this is the 500 micron, 5 millimeter. So I can choose that length. Telling that as my set scale as my 5 millimeter. Tell that is my 5 millimeter. Global. I can do that, or I can take my scale bar and tell analyze set scale. That is 1 millimeter. It's pretty close. You can see it's telling 0.95. It's pretty close. And global shutter, okay. So now if I reduce it, I go to analyze, tool, scale bar, and I choose around 10 millimeter scale and color white, background black. Here is the scale bar. So there are many ways the scale bar can be placed, either by image J or by third-party whole slide viewing software, or by the scale bar that Microvisioneer is giving. And then you can enlarge it. You can crop in certain portion, and you can crop the certain portion. Like that, you can crop certain portion, and you can save that as a JPEG or TIFF PPL copy. Cropped one. That's how I choose different cropped portions. So that's how I can crop, and I can still retain a very high resolution from this original image. So once you have the original whole slide scan, you can do multiple processing options with the whole slide scan. This is the crossed polar one. You can beautifully see the crust limestone and the crust granite quartz aggregate. Let's go to the copy one. Keep the original one intact. Crop. I like to get rid of the edges. You can clearly see the distribution of crust limestone. I don't need to play with the brightness, contrast, anything. It's already scanned in a very nice brightness. So you can see now the distribution of crust limestone, the shell particle, the argillaceous limestone, the crust granite, the siliceous calcareous sand fine aggregate, the coating, the urethane coating with the quartz filler. Lot of information can be obtained from this whole slide scanned image. So that's how a lot of processing can be done with the whole slide once you scan it. Let me show you quickly. You can open like the PPL copy. Then you can go to image. You can have a 84-bit image, and you can adjust the threshold, and you can determine where the air voids are by playing with the threshold values, the color threshold value. Then you can choose process binary. You can make a binary image, and that will show you the distribution of the sand particles or air void, whichever you want to highlight. Here it's highlighting all the sand particles, and you can do measure, you can determine the sand content from the binary image. So you do a 8-bit image from the color, you do a color threshold, and you select the area of interest that you want to analyze. Then you can do the measure, you can do the distribution to determine the sand size distribution. All those aspects would be a different video once you get the scanned image, how to process the scanned image. But this video mainly shows how you can get the whole slide scan of an entire 50mm by 75mm thin section using Microvisioneer's whole slide scan, whole slide imaging software. Thank you.